In this video we will consider the following problem. An airplane flies at distance L from a radio transmitter and it receives a signal of given intensity. We need to find electric and magnetic components of the signal and the power emitted by transmitter if we know that it radiates uniformly over a hemisphere. First, we will find amplitude of the electric component. To do this, we will use the equation which you can find in textbook. It involves unknown component EA and given intensity of the transmitter. From this equation, we can get equation for electric component. Here c is the speed of light, epsilon naught is permittivity of free space, and using the numbers we get the result for EA squared. Here it is, and finally it is given by this number. The last step, we take square root from the left hand side and right hand side of this equation and get the answer in a simple form using prefixes. 87 millivolt per meter. This is the amplitude of electric field at the point of location of airplane. Now we will find amplitude of the magnetic component of the signal at the airplane. We can do this in two ways. First way is to use this equation for intensity as function of amplitude of magnetic field. Here we use exactly the same way as we used previously, taking into account that here we have permeability of free space, which is given by this number. And we can find a magnitude of B. But here I would like to show you another way, which is based on the another equation for intensity as function of magnitudes of electrical and magnetic components. Electrical components we have found previously, and from here we immediately get the equation for B, not for BA squared, as we would have if follow the previous way. So everything here is given, and we can calculate B immediately, and BA is equal 0.29 nanotesla. This part of problem is solved. The last part of the problem is to find power transmitted by the source of electromagnetic waves. And this power is defined as a product of intensity of electromagnetic waves at given point times area through which the electromagnetic force are passing. In our case, this area is a semisphere with the center in the source and radius equal distance to the plane. We know that the area of the hemisphere is 1/2 of the area of the entire sphere, so it is 2 pi L squared. Using this, we can find equation for power of the source in this form. Everything here is given. In the right hand side, we can plug in the numbers, calculate them, and because we have only two significant figures, the final answer looks like this. And the problem is solved completely. If you like this video, you may want to click like button, leave a comment and subscribe to it.